Review number 2. 400 draws will be made at random with replacement from the box 1357. Estimate the chance that the sum of the draws will be more than 1500. Estimate the chance that there will be fewer than 93s. So my box is 1357, and I need to run a one variable stat. Why do I have to plug this one in my calculator? There are more than 2 types of tickets. If there are only 2 types of tickets, you can do the SD shortcut. But we don't have that option right here. So 1, 3, 5, and 7. And I'll run a one variable statistics. And I get the average of the box is 4, and the SD of the box is 2.34, 2.24. Okay, so my expected value for 1500 draws is simply going to be 4 times 1500. So I expect 6,000 plus or minus 2.24 times the square root of 1500. So 2.24 times the square root of 1500. Okay, does everybody understand that? Find that, oh wait. Oh, why didn't you guys stop me? This is 400. I'm sorry. 1500 is what we're shading. So 4 times 400 is 1600 plus or minus 2.24 times the square root of 400 is 20 plus 44.8. So I want to know if my expected value is 1600, I want 1500 or greater. So that's going to be this shading here. That has a value of minus 100. We'll divide that by 44.8 to get our z-score. So negative 100 divided by 44.8. And I get a z-score of negative 2.23. So clear draws. And we'll shade norm from negative 2.23 to 5. And I get an area of 98.7. Okay, any questions there? All right, the next part, part B says, estimate the chance that there will be fewer than 93s. Can I use this box here? No, why not? This is a sum box. You can only use it when you're adding the dice together, or in later chapters when you're finding the average of the dice, which is essentially adding the dice together and then dividing by the number of draws. This is not a counting box. So if I create a counting box, what goes inside of it? A counting box will always have what 2 numbers in it? 1 and 0. Okay? And how many 1s does this box have? Oops, I did that backwards. Why does it have only a single 1? In the original box, there is only 1 3, and that's what I want to count. So what are the other tickets? 3 copies of 0. And those zeros represent the numbers 1, 5, and 7. And a 1 and a 5 and a 7 all mean you lose. So we're counting all of those as zeros. So our sum of the box is 1. Our average of the box is 1/4. And can we do the SD shortcut? Yep. 1 minus 0 times the square root of what two fractions? 1/4 and 3/4. So the square root of 0.25 times 0.75. And that is 0.43. Why is that SD so much smaller than the SD of the previous box? No, it's not. We haven't calculated draws yet. Why is this SD 0.43? The old SD was like 2.2. Why is that? Well, this box is way more spread out than this box. And SD is a measure of spread. The numbers in the top box are a lot further away from the average of 4 than the numbers in the bottom box are from 1/4. Okay, so we're going to do 400 draws. If we do 400 draws, how many 3s do I expect? I expect 100. And I could times this by 400 and get that number. But in this case, it just makes sense to reason through that. And I want to know fewer than 93s. So I want to shade from -5 to whatever the z-score is that represents a value of -10. So -10 divided by 0.43. Wait, what am I doing? I need an SE. So 0.43 times the square root of 400 is just going to be this number times 20. And that gives me a standard error of 8.6. My value is -10. So -10 divided by 8.6 gives me a z-score of -1.5. So now I will shade norm from -infinity to, what was it, 1.15? Yeah? And my area is equal to 12.5%. So if you play this game 400 times, you have a 12.5% chance of having fewer than 93s. Okay, number 4. A coin is tossed 25 times. Estimate the chance of getting 12 heads and 13 tails. What goes in the box? 0 and 1. Okay, so the average of the box is 1/2. The SD of the box is 1/2. And we want to know what is the chance of getting 12 heads and 13 tails. How do you do both of those at the same time? You do one or the other, right? Okay. So we need an expected value. What is the expected value of, let's say, 12 heads? So what is the expected value for the number of heads in 25 draws? How many heads do you expect in 25 draws? Half of them are supposed to be heads, so it's going to be 12.5. And then the SE will be 1/2 times the square root of 25, which is 5. And 1/2 times 5 is 2.5. So we want to shade only the column that represents 12 heads. My average is 12.5. So what are the bounds on the column for 12? Oop, I drew that wrong, didn't I? I guess I didn't. So here's 12.5, but it's not the top of any column. We have over here 12, and then we have over here 13. So what are the bounds on the column representing 12? 11.5 on the left side to 12.5 on the right side. So this is 11.5 and that's 12.5. And then if we did that with tails, we would get the exact opposite, which would be a different graph, and we're not going to mess with that. So I need a shade norm from whatever z-scores are created for those numbers. And they're both, well, the first one is -1, and the second one is 0. Does that make sense? Those are the values. So -1 divided by 2.5 and 0 divided by 2.5. -1 divided by 2.5 gives me a left z-score of -0.4, and then my right z-score is just 0. So we'll shade norm from -0.4 to 0. And I get 15.5%. So you should have got 15.5. All right, number 6. A programmer is working on a new program coin to simulate tossing a coin. As a preliminary test, he set up the program to do 1 million tosses. The program returns with a count of 502,015 heads. The programmer looks at this and thinks, 2,015 off. That's a lot. No, wait. Compare it to the million. 2,000, forget the 15, out of a million is 2 out of 1,000. That's 1 in 500. 1/5%. Very small. Good. Coin passes. Do you agree with him or not? Yes. So, is 2015 a lot to be off? Well, the more tosses we do, what do we expect to happen to the absolute error? It's going to get bigger. What do we expect to happen to the percent error? Get smaller. And the absolute error is growing slower than the number of tosses, which is why the percent error goes down. So is the machine okay? Probably. All right. And number 9. 100 draws are made at random with replacement from a box with 99 tickets marked 0 and 1 ticket marked 1. True or false? The sum will be around 1, give or take 1. True. So in my box, I have 99 copies of 0 and 1 copy of 1. What is the sum of the box? 1. And the sum of the box represents what happens when all of the tickets are drawn out. So if we draw 100 times, that's how many tickets are in the box, we expect our sum to be 1. Okay? And it says my expected value is 1 plus or minus 1. What is the SD of the box? 1. How come? Well, the average of the box is 1 divided by 100, which is 0.01. How far away are these numbers from that number? 1, right? The number 1 is 0.99 away, and all of the zeros are 1.01 away. So how far away are the numbers in the box from the average? 1. Okay. So true or false and explain. The sum will be around 1, give or take 1 or so. So we need to calculate the SE. The SD of the box is going to be 1 minus 0 times the square root of 0.01 times 0.99. And I get an SD of 0.099. Now I need to times that by the square root of 100, times it by 10, and what do you notice? It's really close to 1. And that's it.